Here in this question here, we are asked to find the length of this line here, line QR. And as you can see, a relationship is given here that this angle here, angle BSR, is twice the size of this angle here. And angle SBR here is twice the size of angle APS. So, and they say line PA here is parallel to this line SR, and this line here is 6 centimeters. So how can we find line QR here? So if you look here, this line here starts from point Q to this point P, and from point P here to point R. Line QB here is a straight line segment on its own, and also BR is also a straight line segment on its own. So since we have the length of this line here to be 6 centimeters, had it been we have the sizes of the required angles, and we can use the sine rule to find the length of this line from this triangle, and also the length of this line from this triangle, and then add them up together so that we can have the length of line QR. Or better still, find the length of this line here from this triangle, and then take up this whole triangle here, use the sine rule and the angle here to find the length of line QR. But in this video, we are going to use the second procedure by finding the length of this line and then using it to find the length of line QR from this triangle. After this video, you can try using the first procedure and see whether you'll get the answer correct. Okay, so now the most important thing to start with is finding the size of each angle we need right here. So now, to find the length of this line here, line QS from this triangle using the sine rule, we need the size of this angle facing the unknown side and this angle here, which is facing the known side. But since this angle here is already known to be 20 degrees, we need to find the size of this angle here. So let's label it angle B. So now to find the size of angle B here, since this is 20 degrees, had it been we had the size of this angle here, we would have been able to find the size of the angle using the rule that says the sum of angles in a triangle equal to 180 degrees. But since we don't have the size of this angle here, let's go back to the first relationship, this relationship here, where they say this angle here, angle BSR, is twice the size of this angle QSB. So we can label this angle X. If we label this angle X, this must be 2X because they say this is twice the size of this. The second relation said angle SPR is twice the size of angle APS. We can also label this Y. So if we label this Y, this will also have to be 2Y. So now if you look from this line here, since this line is parallel to this line, and this line is also a straight line intersecting both, we know that the sum of this angle and this angle must be equal to 180. So we can form an equation y plus 30 degrees plus x plus 2x equal to 180 degrees. X plus 2x equal to 3x. So this will be y plus 30 degrees plus 3x equal to 180 degrees. Now collecting the like terms, 30 degrees will have to be subtracted from both sides. So after subtracting, this will be y plus 3x equal to 180 degrees minus 30 degrees. 180 minus 30 degrees is 150 degrees. So y plus 3x equal to 150. So now, in this equation, we have two variables to be unknown, and it is impossible to find their values from only this equation here, and hence we still need another alternative. So let's recheck the figure if there is something we can get from it. Now, if you look at this angle here, you will notice that it is an exterior angle of this triangle here. And if you can recall, in the triangle rule that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. And therefore, this angle equals to these two angles here. So you can form an equation once again that 2y equal to x plus 20 degree. Here also, collecting the like terms, x will have to cross the equal sign, and therefore 2y minus x equal to 20 degree. So now we have this equation here, and recall this our equation here, y plus 3x equal to 150 degree. So what we can do now is to solve the equations simultaneously. In mathematics, when we are to solve two equations simultaneously, we either solve it using the elimination method or by substitution or matrices. But in this video, we are going to solve using the elimination method. In the elimination method, we just take up a variable we want to eliminate from each equation. So here, let's try eliminating y. So now, to eliminate y, we need y to have the same coefficient in both equations. But here, the coefficient of y is 1, and here 2. So now, to make y have the same coefficient in both equations, we multiply the coefficient of y from this equation, which is 1, by this equation, and also the coefficient of y from this equation, which is 2, by this equation. So here, 2 multiplied by y is 2y, 2 times 3x is 6x, and 2 times 150 degree is 300 degree. So here 2y plus 6x equal to 300 degree. But here in this equation will not change because it was multiplied by 1, and anything multiplied by 1 does not change. So now 2y plus 6x equal to 300 degree and 2y minus x equal to 20 degree. The next step is to subtract the second equation from the first equation. So here 2y minus 2y is 0, plus 6x minus x is 7x, because minus times minus is plus, and 300 minus 20 is 280. So now we are left with 7x equal to 280 degree. To make x the subject of the formula, we divide both sides by 7. So 7x over 7 equal to 280 degree divided by 7. Here 7 cancels 7, and here 280 degree divided by 7 is equal to 40 degree, and hence x equal to 40 degree. So now, since x equal to 40 degree, to find the value of y, we just substitute the value of x into any of these two equations. Let's substitute it here. 2y minus x equal to 20 degree. Substituting x equal to 40 degree here, 2y minus 40 degree equal to 20 degree. So to find the value of y, we add 40 degree to both sides. Now, 2y minus 40 degree plus 40 degree equal to 20 degree plus 40 degree. Here, minus 40 degree plus 40 degree is 0. 20 degree plus 40 degree is 60 degree. So 2y equal to 60 degree. Dividing both sides by 2, here 2 will cancel 2, and here 60 degree divided by 2 is 30 degree, and hence y equal to 30 degree. So now we have x to be 40 degree and y to be 30 degree. If we substitute here, y equal to 30 degree, this will be 30 degree, and here 2y will be equal to 2 times 30, which equals to 60 degree. Now substituting x equal to 40 degree into this angle will be 40 degree, while here 2x will be equal to 2 times 40 degree, which equals to 80 degree. Coming back here, since this is a straight line and this is 60 degree, this must be 180 degree minus 60 degree, because the sum of angles on a straight line equal to 180 degree. 180 degree minus 60 degree is 120. So this angle here is 120 degree. So since we finally found the size of this angle here, we can find the length of this line here, line QS, from this triangle. So using the sine rule, 6 over sine 20 degree equal to line QS over sine 120 degree. So solving for QS here, making QS the subject of the formula, line QS will be equal to 6 over sine 20 degree times sine 120 degree. Sine 20 degree is 0.342 and sine 120 degree is 0.866. So now line QS equal to 6 over 0.342 times 0.866, which equals to 15.1929, approximately equal to 15.2 cm. So we found the length of line QS to be 15.2 cm. But recall in the question, it was the length of this line QR we were asked to find. So now, if we are to consider this triangle here, triangle QRS, to find the length of line QR, we still need the size of this angle here. So, since these two angles are known, we can label this angle Z and form an equation: 20 degree plus 40 degree plus 80 degree plus Z equal to 180 degree. 40 degree plus 80 degree is 140 degree. So 140 degree plus Z equal to 180 degree. Subtracting 140 degree from both sides, Z will be equal to 180 degree minus 140 degree, which equals to 40 degree. So that means this angle Z here is 40 degree. Now using the sine rule to find line QR, 15.2 over sine 40 degree equal to line QR over sine 40 degree plus 80 degree. Now making line QR the subject of the formula, line QR equal to 15.2 over sine 40 degree times sine 40 degree plus 80 degree is 120 degree. So sine 40 degree is 0.6428 and sine 120 degree is 0.866. So now line QR equal to 15.2 over 0.6428 times 0.866. Press your calculator, line QR equal to 20.4779, which approximately equal to 20.5. So we found the length of line QR to be 20.5 centimeters.